Here, let's go ahead and go through this. In a solid state, the hydrogen bonds in water freezes into what? And it's going to be a hexagonal shape. So that is correct. I will go ahead and show you in just one moment as a reference. But there we go. They will be in a hexagonal shape. There we go. All right. And so then obviously, which results in the solid being what? And it's actually going to be lighter, less dense. And the reason being for that is because there's more space in between that hexagonal shape. I will show you in just one second. So it will float, and absolutely correct. It will float here. So let me go ahead and reference this for you. If you take a look at this slide here and looking at the ice, you'll notice that hexagonal shape there. And as you notice that there is more space in between those bonds, and this is a perfect one up here, the space between those bonds allows for it to be less dense, allowing for ice to float. That's why you may think that, ice is a solid. Why is it not sink? It's because of that hexagonal shape. It actually floats in water. Okay, just a little review from yesterday. Absolutely. So let's go ahead and head back here. What is a goal that you would like to meet or work on in the next 5 years? A goal can be anything. I'll cross the board here. I love seeing this. I want to own a business. That is awesome, Maylin. Take the family company, May. That's super awesome. I want to be a singer in a group. That is so cool, Miles. And that is super neat. Love to do that. I think what I've been telling my other classes, I think with everything, I would like to be more, a goal of mine would be more at peace with myself and more at peace with everything that is going on. I feel like time is going by so fast. I just need to take a moment to be at peace and to live in the moment and see my children grow up, and just instead of going, let's go, 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 I just take a deep breath and learn those skills to be mindful of the now, not the later or the past, So again, I think that's a good goal that I'm going to try to work on, because I feel like I get caught up in the moment and miss those important things with my kids and those important things with my friends, my family, all of that stuff. Yeah, exactly. Want to be a little more healthy mind and body. Absolutely. That's such a good one, Shelbs. All right. So let's go ahead and move on here. Remember, Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and protection of others. And make sure that you're always respectful and school appropriate. All right, so with that being said, here is our attendance. It's going up into the chat box one more time. Click on the links. Again, if one link doesn't work, try the other link. I mean, this is day 30, so just to kind of shoot that out there. Again, look at that, look at that. I can't even read that. 26 seconds up on the clock. Please get your hands raised. Let's go ahead and get that up there. Again, we have the first 15 minutes of class. Remember, we close at this closes at midnight technically, so you can copy it down and then obviously get it into your get your attendance in. So with that, let's go. We're at, it's red, so we're down to less than 5 seconds. And there we go. Let's go. I'm going to go ahead and start calling people out. Miles, Michael. Thank you. Perfect. People are moving. May, excellent. Kamari, Christopher, Annabelle, I see you in the chat box. Angelo, Patrick, go ahead and let me know in the chat box. Dion, Gabriel, let me know in the chat box. Good morning, Gabriel. Let's see, Kale, Eric, and Anthony. Please raise your hand. Thanks, Eric. Thank you so much. I see you in the chat box. Beautiful. Tayan. Thank you. Perfect. So May, Annabelle, you're good. Dion, Gabriel. Good morning, Christopher. Good morning. Awesome. Thank you, Gabriel. And Anthony, Tayan, and Alan. Let's get our attendance here. Remember, we call you more than 3 times. You will be excused for non-participation. Just kind of let you know out there. All right, let's go ahead and move on. Just like I said earlier, it is day 30 of our 60-day adventure together. I cannot believe it. We're halfway through, folks. Halfway. It is Wednesday, January 20th, and we are talking about metallic bonds today. And we're going to do this all through our chemistry Unit 3 friendship projects in our slides. So let's go ahead. Look at that, halfway. All right. When I'm here, my mom's talking about you. Yeah, you got to make sure that you're talking correctly. Unit 3 Friendship Project due Friday, January 22nd. That is this Friday. 2 days, 2 days away. 2 days. You cannot say that you didn't know. It is January 22nd. So this Friday, we will be turning in our Unit 3 project. All right. Thank you, Mrs. Larkin. We're going to identify the properties of metals. We're going to explain how metallic bonds result in the properties of metals, and we're going to do this all through our slides 43 through 47. We are winding down on this project, so let's make sure we get our 100% participation in.
Excellent. All right. So we need to go ahead and get our projects open and ready to go. So please raise your hand when you have them open and ready to go. If you started it in Google, here is the Google Slides folder right there for you. If you started it in PowerPoint, obviously open it up in PowerPoint. And if you have not yet started it, again, as mentioned, it is due on Friday. We are going over the last content today. So please, let's get it open now. Let's do this together. It's a short project. There are only 7 project slides, and we have recordings that are going to go over them step by step. We already went over chapter 1 and chapter 2 together. Tomorrow the recording will go over chapter 3 and the reflection together. Nice short recording there. And then everything else is notes, which is everything that we've done in class together. We give you all the answers in class, so you should be really successful on those parts of the project. So please go ahead and raise your hand. Again, if you need it, it's in the grades tab. Scroll down to the Toy Story picture, click the Google Slides version and make a copy, or click the PowerPoint version to download it. Let's see here. We have 20 seconds. I'm going to give you 20 more seconds to raise your hand. I'll do a quick read off. Monty, Ignacio, Tayan, Anthony, Eric, Lydia, Gabriel, Dion, Canyon, Patrick, Jaden, and Ame. Annabelle, I see you in the chat. Thank you. Again, raise your hand or send us a chat. Let us know that you are here and good to go. Thank you, Gabriel. I see you in the chat. 3 seconds. All right, we're looking at Dion, Tayan, and Ignacio. Ignacio, I'm pretty sure you're there. Let me know if you're good. Thank you, Anthony. Thank you, Kale. Steven, let me know if you have your project open, ready to go. I think you might have just joined us, so let me go. No worries, Steven. Let us know if you are good to open up your project, though. I'm confident you are. Tayan, Ignacio, where are you at? Thank you, Ignacio. Tayan, just waiting on you. You're our last one. Please raise your hands. I'm going to go ahead and move us along, though. Here we go. All right, so if an atom only has a few valence electrons, what's it going to do in order to become stable and happy? Will it lose the few electrons, or will it gain more to try to get to a full octet? Let's go ahead and take a look at some examples. So we've got group 1, 2, and 13. These all only have a few valence electrons. Group 1 has 1, group 2 has 2, and group 13 has 3 valence electrons. So if we have 1, 2, or 3 out of the octet, which is 8, what are they going to want to do? Do they want to lose those 1, 2, or 3, or gain more to get to 8? What do you think is going to be easier? Tell me in the chat. Tell me in the chat. What will they want to do? Lose the 1, 2, or 3, or gain more to get to 8? What's going to be easier? Lose 1, 2, 3, or gain 5, 6, or 7 to get to 8? Yeah, the question is gain or lose, so you got to choose one. Thank you. Yeah, it's going to be easier to lose, right? It's much easier to lose 1, for example, than to gain 7, right? It's going to be easier to lose 2 than to gain 6, and easier to lose 3 than to gain 5, right? So much easier to lose than to try to gain a bunch more to get to 8. So that will make them stable. That will make them happy. What I want you to notice here is, again, groups 1, 2, and 3 are all of our metals, right? We can see some really common examples that you should be familiar with: sodium, potassium, calcium, magnesium, and aluminum. Those are all metals you've probably heard of at some point, and they are all in group 1, 2, and 3. And today we're talking all about metals, so that should make a lot of sense. Let's review some properties of metals today, and then we're going to discuss why do these metals have these properties. So you should already know these. These are what we talked about in Unit 2, but today we're going to go ahead and go even further into it and talk about why do they have a lot of these properties. So first off, metals tend to be lustrous, which means shiny, which every time I hear the word shiny, I now think of Moana and the shiny crab because my daughter loves that song, and so I listen to it all the time. But anyways, they are also malleable, which means that you can make them into sheets, right? You can hammer them into sheets. And ductile, which means you can turn them into wires like you see up here. Now, I do know that malleable and ductile sometimes get a little bit confusing. The way I remember it is malleable is a bigger letter, like M is a bigger letter, or malleable in general is a bigger word. And so that reminds you of like something bigger that's a sheet. Ductile, the letter D is smaller, or again, ductile itself is also a smaller word. And so that kind of reminds you that it's smaller, it's a wire. Okay, and they are also good at carrying electricity and heat. Remind me in the chat box, what's that term for the ability to carry electricity and heat? It starts with the letter C. It's the opposite of an insulator. What's the opposite of an insulator? You all right there, Ignacio? Yeah, exactly. These are called conductors. Great memory there. These are called conductors. Good, referring back to some old vocabulary. So yes, they are good at conducting or carrying electricity and heat. Again, everything we should already know. We're very familiar with metals in our everyday lives. We're going to talk about later on why this happens.
So let's go ahead and lock in our slide for number 43. This is going to be conductors. Again, conductors of both electricity and heat. They are good, metals are. So I want you to lock in your answers. We're only going to give you 20 seconds to do this. Conductors, 20 seconds up on the clock. Raise your hand when you are finished. Raise your hand, nice and proud and high. Let's go, 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 go. Let's get our hands up really fast. I see Annabelle in the chat box. I see Steven in the chat box. Awesome. Let's go ahead and check in with people. So we have Angelo. Go ahead and raise your hand. Dion, Angelo, Dion, Eric, Alan. Get our hands raised. Thank you, Gabriel, Angelo, Dion, and Adriana, Dion, and ooh, we're moving. Sorry, we're moving fast. Angelo and Dion. Angelo and Dion, please raise your hand. I will check in with you. I've already checked in a couple of times to some of us. Angelo and Dion. All right, let's go ahead and move on. So let's take a look at this particular practice here. We know that is lustrous, malleable, ductile, and conductor are all terms that describe metals. So I want you to go ahead and use your line tool, and I want you to define what those terms mean. I'm only going to give you 15 seconds to do that. Let me give you your whiteboard tools. There you go. So use that line tool. Remember, you go to that hollow box, you find that line, and then you go ahead and go across. Please don't use your pointer. That's not going to work, but using your line tool will. So 15 seconds up on the clock. Go, go, go. All righty, I'm going to go ahead and put our whiteboard tools on hold. I'm going to clear this out. You did a pretty good job, and I'm just going to clear it out so we can see it correctly. So I'm going to grab my line tool. Now I'm going to use red. Lustrous, again, is a synonym for being shiny, so nice and shiny. And again, that song that Mrs. Larkin says is stuck in my head right now. Thank you so much. Malleable, again, it can be hammered into sheets. So again, like the trick she said, malleable sheets, big. So M is a bigger letter, malleable sheets. Ductile, again, it can be pulled into wires. D is lower or higher up on the alphabet. So again, smaller wires are going to be smaller, so ductile. And then finally, conductor is ability to carry heat and electricity. Excellent job, everybody. Let's go ahead and move on. This was just some practice for you.
Excellent. All right. So metals only have 1 to 3 valence electrons. So we kind of went over this during our brainstorm. So again, what will they prefer to do? Gain or lose electrons? Go ahead and tell me in the chat box. If you only have 1 to 3 out of your 8, your octet, will you prefer to lose them or gain more to get to 8? Tell me in the chat. Again, we already know the answer. We went over it like 3 slides ago. Yes, they will prefer to lose. Again, they will try to lose those electrons so that they can drop down to a shell that's already full. Let's go ahead and take a look at an example. example here so we can see sodium. Sodium has one valence electron right here, and so it's going to try to get rid of that valence electron, give it away, and so now it's gone. And what we can see here is that it's going to drop down to a shell that's already full. So this second shell right here, every shell underneath is already full, but the second shell has 1, 2, 3, 4, 5, 6, 7, 8. So now sodium is happy. Now, if you lose an electron, you're losing a negative electron, you're losing negativity, you should become overall what? Tell me in the chat box. If you're losing negative electron friends, you should actually become more what? Thank you, Annabelle. Thank you, Daniel, Gabriel. Yes, you actually become more positive. So this sodium is going to become positive. Remember, positive ions are called cations. So we've got, oh, come on. Why do my tools here never want to work with me? Give me a moment. Here we go. So this is going to become a positive cation. And remember, it's going to actually give that electron to somebody. So it's going to actually give its metal ion to a nonmetal. And now that nonmetal has gained negativity, that nonmetal becomes a negative anion. And now we have an ionic bond, which again is the attraction between a metal positive cation and a nonmetal negative anion, which occurred because they exchanged or transferred electrons. All right, so that's just some quick review from a lesson from a few days ago. Smiley faces, emojis, if you understand that, if that makes sense, if you remember that as a review. Thank you, Annabelle. Thank you, Ignacio. Thank you, Miles. Is that a good or a bad emoji? I don't know. All right, looking good. Let's go ahead and work on our next fill in the blank.
Let's take a look at slide number 43. So obviously slide 43, we're going to put the word lose, okay? Because again, metals want to lose about 1 to 3 valence electrons. They want to drop down to that full shell. So lose will go right there in the highlighted spot. I'm going to give you about 20 seconds to that. I see people already working ahead. Awesome job. Thumbs up on that one. So it shouldn't take that long. 20 seconds up on the clock. Go, go, go. 10 seconds. Here, let's check in with a few people. Let's get 100%. So looking for Michael, Jaden, Kamari, Annabelle, you're good. Gabriel, you're good. I see you in the chat box. Ooh, we're moving. Oh, so Stephen, you're good. So Tayan, Arya, and Michael. So just 3 people, Michael, Arya, and Tayan. Tayan, Michael, and Arya. All right, let's go ahead and move on. Thank you so much.
All right, I just sent out that attendance one more time, so please make sure you get that attendance. I will be erasing it in just a moment. And then Mrs. Pulvito, once you're good on those check-ins, make sure to lower those hands for me. All right, so let's go ahead and talk a little bit about where do these come from. Sorry, let me go ahead and erase the chat now, so we're all done with our chat there. All right, so let's go ahead and talk about where do these properties actually come from. So these properties come from the structure of metals or from what we call metallic bonds. So in a metal, the metallic atoms are very closely packed together and they're highly ordered. Ordered meaning that they're kind of set up in a pattern or a very specific structure. However, in this specific structure, metals still want to give away their valence electrons. Again, they only have 1, 2, or 3 valence electrons. They're desperate to get rid of them. They do not want those valence electrons, so they will still give them away. And again, if you're giving away negative electron friends, they should become what? If they're giving away their negative electron friends, they should become what charge? Thank you. I see Annabelle's got it in the chat box. We just reviewed this. Let's get some more participation. Again, we're trying to reinforce our learning. Thank you, Gabriel. Thank you, Stephen and Camilla. Yeah, they'll become positive. So now we have a bunch of positive metal ions here. Again, they have to be positive because they've given away their electrons. But this is a little bit different now. So what used to happen, right, is they would give their electrons away to a nonmetal and you create that ionic bond that we just talked about. However, this time they're actually giving away their electrons, but their electrons have no place to go. So this is what is called electrons being delocalized. So local meaning like you're staying where you belong, delocalized meaning you're leaving where they belong. So delocalized, so now they can actually move freely. They can move all over this structure of positive ions. So the positive ions all stay in place, and now these negative electrons are going to be running around this structure. All right, they're like naughty kids. So we have all these little negative electrons running around the place. They are moving freely. Smiley faces, emojis, if that's making sense. I'm going to go ahead and actually share this with you up on the board so that you can see a better picture of this. So here we go. Let me share this with you. So again, what you can see here is we have these gray ions right here. And these, again, have to be positive because they've given away their negative electrons, so they actually become positive. So we have all these positive metal ions here, and then the negative little electron friends that they gave away are now moving freely and all over the place. Freely and all over the place. Awesome. All right. Yeah, everyone can see that? Looking good. All right, let me go ahead and jump back over to our slides here. And here we go. All right, so that is going to be our next one. If I can move slides, here we go.
Is going to be on that first left-hand side. So left-hand side, it's going to be freely. So you're going to put the word freely in there. Go ahead and start getting your word into the chat or into your project and raising your hand. Again, I'm only going to give you 20 seconds. This is a pretty easy word. Go, go, go. Raise your hand, please. Perfect. Here we go. So looking for Jaden, Kamari, Annabelle, you're good. I see you in the chat box. Let's see. And we're moving around. Sorry. Kamari. Ooh, whoa. Stop moving. Kamari, Dion, and Alan, and you're good. Alan, Dion, and Kamari. Alan, Dion, and Kamari. Please raise your hand. Thank you, Kamari. I see you up there. And Dion, and thank you, Gabriel. Dion and Kale. I think Kale, didn't you raise your hand before? Dion, we're just waiting for you. You're my last person. You're my last person. Let's go, Dion. Dion, Dion. Hello, Dion. Last person. All right. I will be checking in with you.
All right, so a way that you will often hear this phrased is that metals are made up of a sea of electrons moving through a matrix or grid of positive metal ions. So you'll often hear that term sea of electrons just to imply this idea of electrons are able to move very freely and all over the place, kind of like a sea, right? So taking a look here again, matrix or grid, you could also call this a lattice. Sometimes you'll hear the term lattice, and all of those mean the same thing. They just mean that the positive metal ions are very ordered and patterned and put in a specific pattern, put in a specific order, right? So matrix, grid, lattice, all of those will work when we're talking about those positive metal ions. Again, these ones have to be positive because they've given away their electrons, and those electrons are like the little kids running around the place, owning the place. They are all negatively charged. So they've given away their negatives. The negatives are all moving around. All right, let's make sure we understand that one.
Remember that matrix is a grid of positive metal ions in there, so make sure you get that word in. Again, we're going to give you about 20 seconds to that. Let's get 100% on that participation. I know we can do it. Go, go, go. Think in my movies, and that was just a thinker. All right, here we go. So let's go ahead and take a list. Jaden, Kamari. Jaden, Kamari. We're moving. I'm sorry. So Annabelle, Dion. Annabelle, you're good. Dion. Gabriel, you're good. Lydia, Eric, Tayan, and I know Tim, you just came into class. And Stephen, you're good. Please make sure that if you just walked into class that you go ahead and open up your notes. Your Unit 3 project. I'm sorry, I have other classes doing notes. So Dion. Thank you, Lydia. Saw you go up there. And Tayan. Dion and Tayan, you're my last two. Tayan and Dion. All right, thank you.
All right, remember you get 3 chances to check in with us, and then you will be dismissed if you're not participating. So please make sure you're checking in with us. All right. So now let's go ahead and put it all together. So we've talked about the properties we already know of metals. We have talked also about the structure of metals. Now we're going to go ahead and put it all together. No worries, Stephen, you're all good. So as a result of our structure of these free sea of electrons moving around these positive metal ions, we have the ability to conduct electricity and conduct heat. Let's talk about why. So metals can conduct electricity because electricity is quite literally defined as the flow of electric charges, and we just said that in metals we have a sea of free flowing electrons, which are negative charges. So here we go, we're taking a look, we have a sea of free flowing negative charges. Those are the electrons. And so quite literally, since that is the definition of electricity, that means that we then have electricity. That's also why they have the same root. Like electricity literally comes from this term electrons, right? Electrons, electricity, they're related to each other. So we have moving electrons, we have electricity. Awesome. Now, they can also conduct heat for a very similar reason because these same exact electrons, again, which are free flowing and moving all around, can very quickly pick up and transfer heat. Now, Usually what has to happen is that a substance has to heat everything up before it can start to transfer heat. So for example, when we talk about water or wood or when we talk about rubber, all of those things are not good at conducting heat. So in order for them to move heat, you have to begin to heat up all of the particles so that all the particles start moving faster so that we can finally start moving that heat. But again, in metals, we already have particles that are moving really fast. Those electrons are already moving. So in metals, we already have fast moving electrons. All right, so we don't have to wait for everything to start moving fast. The electrons are already doing that. And so that is why metals heat up much faster and move heat much faster than things that are insulators like wood and like rubber, etc., etc. It's not really a reaction. It's the movement of heat. Moving heat is not a reaction. So moving heat is just particles beginning to move faster and faster and moving that heat through a substance. All right, smiley faces, emojis, everyone, if you feel comfortable with this. Again, how this connects the metallic bonds and the properties that we've been talking about. Excellent. All right, let's go ahead and work on slide 45.
There's electric charges, and then we have the word of transfer, that those flowing electric charges transfer that heat and move it all throughout. So let's go ahead and put that in. Raise your hand when you are finished. I'm only going to give you 25 seconds. Because there's 2 words, I'll give you 5 more seconds. So 25 seconds. Here we go. Go, go, go. Yep. Annabelle, you're good. Shelbs, thank you. I see that popping up. People are moving on me. So I'm just going to go ahead and just kind of go down. Eric, Ignacio, Kale, Tim, and Stephen, you are good. Just let me know again in the chat box. So Ignacio and Tim are my last 2. Ignacio and Tim. Ignacio and Tim. Ignacio, hello. I'll sing the song. Tim. All right. I'll go ahead and check on a few of us.
All right, so let's go ahead and talk also about the other properties we talked about, which were malleability and ductility. Again, malleability, we talked about the ability to turn metal into sheets, and ductility, the ability to turn metals into wires. Now, again, this is due to their structure, all right? So we talked about the metallic bonds, those positive metal ions, which we can see right here, which are highly, highly ordered and structured. So first off, this helps because we can just kind of slide them past each other. So they're not all tangled up, they're highly ordered and structured, and so you can actually pull them past each other, which allows us to make wires. But in addition to that, they're not going to break apart from each other very easily because those electrons, again, are moving around and can kind of fill in any spaces as you try to pull the metal, which prevents it from breaking. So where you would normally have a break, those electrons can move in there and fill in those spaces and reform their metallic bonds to prevent the metal from breaking. So that is why metals are not brittle like a lot of non-metals are. They won't just crumble or break apart when you pull on them or when you hammer them into sheets, because they have these metallic bonds that can easily be broken and easily reformed. Then as you move the metal ions around, the electrons just kind of fill in the spaces and everybody is still happy. Everybody is still happy. Awesome. Let's go ahead and fill in slide 46.
Let's go ahead and get our This is only one word, so I'm only giving you 20 seconds. You should, strategy is probably to put it in as we are walking or going through it. Thank you, Mrs. Larkin. I was trying to get that for Miles. It sounded a little weird. All right, here we go. 20 seconds up on the clock. Raise your hand. Go, go, go. Pieces are in there. You lost your chair. What? Gabriel, what? Time. So checking in with Bryce, May, Jaden, Derek, Kamari, Annabelle. I see you in the. I know it's 20 seconds right there. I did it in my head. I did it in my head. So looking for Ignacio, Patrick, May, Bryce, Tim. Go ahead and raise your hand. Thank you so much, Bryce. Thank you so much, Patrick. So again, Tim, you're my last person. Tim. Oh, no worries, Ignacio. We were worried about you. We didn't hear from you. All right, thanks, Tim. Here we go. 100%.
All right, so I'm going to go ahead and give you whiteboard tools, and based on everything we've learned in class, I want you to tell me which of these statements are true about metals. Again, there's going to be more than one statement here that is true. So metals are not ductile, metals are malleable, metallic bonds have a matrix of negative ions, metallic bonds have electrons that flow freely, and metallic bonds cannot be broken. Go ahead and circle or box all of the correct statements up on the board. If you cannot circle or box, you got some letters there too, so you can also tell me the letters in the chat box. But let's try to get as many people up on the board as we possibly can. I'm going to go ahead and I think we're good to lower these hands, right? Am I good to lower these? Perfect. All right, go ahead and get your answers up there. Excellent. I see Gabriel working up on the board. I see Shelbs in the chat box. Need more participation up on the whiteboard. Thank you. I see Anthony working hard. Get your answers up there. Want to see participation from Bryce and Michael, Ame, Jada. Get your answers up on the board. Want to see Daniel and Derek. Get your answers up there. Thank you, Annabelle. I see you in the chat. Thank you, Anthony. Thank you. I see Camilla up there. Let's get Derek and Kamari, Christopher and Jade Lynn. Get your answers up there. There we go. Getting some more people up there. Stephen and Timothy. Stephen, I know you're on your phone. You can just tell me in the chat. Taylor, Kale, get your answers up there. Looking good, everyone. All right, let me go ahead and pause these tools. I don't know why we're raising our hands right now. I'm not asking for anything right now. All right, let's go ahead and take a look here. So we said B, C, and D. There's actually one of those that is incorrect. So we're going to go ahead and go over the correct answers here. So metals are not ductile. That's definitely not true. Metals are in fact ductile. So we would have to cross out that word to make that true. Metals are malleable. We got that one. And metallic bonds have a matrix of negative ions. If we're giving away electrons, should we become negative or positive ions? If we're giving away negativity, negative friends. Yeah, so this is actually not a true statement. There is a matrix of ions, but those ions, again, are actually positive. Smiley faces emojis if that correction makes sense. Again, I know that's kind of a tricky one, but we do need to specify that they are positive. Metals become positively charged. Excellent. And then the next correct one is metallic bonds have electrons that flow freely. Again, they gave away the negative electrons. The negative electrons have no place to go, so they just kind of run around the place. And metallic bonds cannot be broken. Again, that is definitely false. They can be broken and they can be reformed. Which again is why they are ductile and malleable in the first place. Excellent job on that, everybody. Let's go ahead and move on to our last note slide of the project. Wow.
So first of all, you're going to be matching the terms for ionic bond, non-polar covalent bonds, polar covalent, hydrogen bonds, and metallic bonds. We have the lessons on this side. I believe that's what this is, the 3B, 3C. Those are the lessons, the last 5 lessons here. Now remember, kind of pulling everything together. An ionic bond is obviously going to be a bond that is sharing or transfer between metals and non-metals. What is that? Non-polar covalent bonds. Think about all of these lessons. Move your slides up if you need to go and review this. I'm going to give you about 2 minutes. Is that good, Mrs. Larkin? 2 minutes? All right. So I'm going to give you a long time here. Again, if you want to check in with us, please do not put any answers in the chat box. Do not put any answers in the room chat, but go ahead and put it in the questions and answers if you need to check in. So 2 minutes up on the clock. Go, go, go. Raise your hand when you are finished. All right, let's go ahead and check in with people. Still looking for Gabriel. You're good. Aria, good. Excellent. So Tayan, Kale, Tim, Tayan, Kale, and Tim. Thank you, Gabriel. I see you up there. Thank you, Tayan. Thank you, Kale. And then just Tim, you're my last person. Tim, Tim, Tim. Go ahead and raise your hand, please. Raise your hand. I know I just talked to you, so go ahead and raise your hand. Excellent. I think we are good, Mrs. Larkin. We almost got 100% there. Perfect. Awesome job, everybody. So slide number 48, but this will be completed a little bit later. Let's go ahead and go through this. These are two simple questions that we are asking you. What is something that went well in this project, and what is something you can do next time to improve your future projects? Folks, please don't put I don't know or nothing. You need to at least put one sentence up there. Do not give us I don't know or nothing. You will get a 0 for this particular slide. It is being very specific. One sentence, that's all we're asking of you to kind of reflect on this project. So make sure that you get that in. Again, easy peasy lemon squeezy. It's just a reflection of these two questions. So with that being said, we've identified the properties of metal. We explained how metallic bonds result in the properties of metal, and we did this all through our slides. We should now be completed with our Unit 3 slides. Of course, they'll be included in a recording tomorrow of kind of the project slides. Congratulations, people. Round of applause. You have done Unit 3. Now, again, if you need to go back for some project slides, Mrs. Larkin will have a recording for you tomorrow. Just make sure you check that out and make sure that you get that in there. All right. So with that, hopefully we are awesome and feeling good about this. Again, if you do need additional help, please call us or please email us. We would be happy to get in there and help you out one-on-one if need be. So I'm going to go ahead and stop the recording